Hello and welcome to Venugopal NEET Academy. Uh, so today we'll look at question number 14 of NEET question paper that was asked in year 2019. So இதை பார்த்தோன்னே உங்களுக்கு தோணும். I mean, what are the different forces that are going to act while the bubble ball is rotating along the hill? What are the different frictional changes that will happen while it is rotating at that particular speed? What is the friction that is caused inside the bubble ball, and what is the friction that is caused outside while it is rotating along the hill? So these are different questions that we need to ponder. So the problem was, if a block of mass 10 kgs is in contact with the inner wall of the cylinder, and the cylinder ulla, which is having a radius of 1 meter, and if the cylinder is rotating along the vertical axis, what should be the angular velocity by which the block will not fall down? Please share and subscribe our channel Venugopal NEET Academy. So the given values are mass of the block, which is 10 kg, the acceleration due to gravity, which is 10 meter per second square, the frictional coefficient, which is equal to 0.1. I mean, the frictional coefficient here is equal to the centripetal force. The radius is 1 meter and theta is 90 degree, pi by 2, which along which it is rotating. The solution here is, when you are going to equate all the forces that are acting on the block while the cylinder is rotating along the vertical axis, you will have the equation to be F, and the other coordinate orthogonal to it, you will have mr omega square, including the frictional coefficient, that is mu. So if you bring both the equations on either side of the uh, equality, so you'll have mu mr omega square, which is equal to mg. Here we have m common, which can be eliminated, and while we are while we are trying to equate and bring only omega on the other side of the equation, it will be equated to g divided by r mu whole power 1 by 2, which is the square root. Since omega is in the square on the previous equation, in the next equation we will try to find only the angular velocity, because that is what is asked in the question. So omega, once we get omega, substituting all the values that we already have, which is g is equal to 10 power 10 meter per second square, r, which is 1 meter, which is the inner radius of the cylinder, mu, which is the frictional coefficient, which is 0.1, and whole power 1 by 2, which is taking the square root. So once you solve it, you get omega to be 10 radians per second. Thank you.